Okay, all right. Well, happy Monday, you guys, and it is week 9, so we are rapidly approaching the end of the quarter. And today I was going to go work through this. I'm going to work through this section 10.2 from the textbook. It just provides a good basic example of doing some classification and things like that. And this is not the only way to do classification in R. But if you're looking for, a little bit of a guide or a model for how it might work, you can take a look, and certainly don't hesitate to ask me for help. Okay, I know it can feel intimidating, but it's not my intention to be intimidating for you guys to approach me for help. So, if you guys are working through things, or if you got some ideas floating around, you can approach me as a group or individually or whatnot. Okay. Hopefully, you guys are making good progress on your group projects. Okay. And so anyway, with Wednesday being the day before Thanksgiving, I will make Wednesday kind of group project advising. So I will not be giving a formal lecture, but I will be here. And if you are here and you are working on your project, which you should be working on your project, and you have any kind of questions, just as simple as, I'm not sure what I should do next. That's rather a complicated thing, or something simpler like, how do I get this is the graph I'm trying to do, and I can't get it to look the way I want it to look, or I'm trying to fit this kind of model and I can't figure out what I'm supposed to do, or what does this output mean. Any of those types of things, I'm happy to help. Okay, and so hopefully you have kind of a better idea of the direction that your group is heading, and we'll do that. I'll also put up a sign-up sheet where you can sign up your group for presenting to me. All right, and so you and your group, you'll have to figure out when it is you want to schedule. And so I'll have slots during week 10 and week 11. Okay, so week 11 is finals week, but I'll have some slots available during week 10 and 11, and you guys will meet, and basically as soon as you are done with your final project, you're done with the course. Okay, you don't, so and again, you have to kind of get group consensus on this. So, but if you take care of it early, then you have nothing to worry about. There's no final exam or anything like that. That is the final grading assessment. Final assessment for the course. And again, I've kind of laid off on the homework and data camp, and again, this was the very first time I've taught this course. This is the first time we've offered Stats 15, and so I welcome any feedback. I think course evaluations will unlock soon, and if you have suggestions for how to improve the structure or things like that, I welcome whatever feedback you have. And chances are in a few years, Stats 15 will look a little bit different. Basically every quarter I teach a class, I always kind of review what feedback I get and try to incorporate those adjustments and changes. That said, I do hope you feel like you've learned a little bit, at least in terms of being able to explore and use the tools to explore your data and get some questions in there. Okay. All right. Any questions, comments before I move on? Okay. All right. Well, let's take a look. So here, this is coming from Chapter 10, Section 2, and Chapter 10 in the textbook is all about predictive modeling. And the idea here is can you create some kind of system, some kind of what we call a model? And the word model in statistics just basically means kind of, if you think about like a model car or a model airplane, it's a small simplified representation of the bigger thing, okay? And what we're saying is we need a small simplified representation of the bigger thing. The bigger thing is the real life process that produces our data, right? So there's a real life process that produces data for how tall does a person end up being, right? And there's a bunch of factors that go into how tall does the person end up being. And things like how old is the person? What is this person's gender? What was the person's nutrition like? What is this person's, genetic, ethnic, or racial background or history? What? There's all sorts of things that could determine how tall someone ends up being, and it's a complicated thing, and we don't know exactly how everything works. But we can create a simple, very, very simple representation of how it might work, okay? And the simplified representation can be as simple as, well, you have the null model is just the average height of everybody is, say, 5'7", and then there's individual differences. Some people end up taller and some people end up shorter. That would be called the null model because we're not taking into any account any kind of predictor variables. Again, why are some people taller, some people shorter? We can just say, hey, there are different genders, and if somebody is male, then they tend to be taller than average, and if somebody is female, they tend to be shorter than average, or whatever else your model might include. Non-binary, maybe we're not going to make an adjustment from quote average, and that's it. That's your model, okay? And again, a very, 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 very simplified representation or version of something much more complicated that actually exists in real life, okay? And so what we will look at today is we'll look at some classifiers, okay? Classifiers, the thing that we are trying to predict is a classification or a category, in contrast to a regression model, where the thing we are trying to predict is a number, okay? So regression models have a quantitative response, basically a number. Classification models have a categorical response, and therefore we have that. And so, one method of classification is logistic regression, and we briefly mentioned that. And logistic regression outputs basically a number between 0 and 1, indicating kind of the probability that you believe it belongs to a certain class. And a lot of these topics, they are covered in different sections in the textbook. So you can, if you want to learn a little bit more about logistic regression, you can go to Appendix E as well. I also posted a small handout about it on CCLE. Okay, so what the data set that we are going to take a look at, okay, it says we're looking at this data set. It says high earners in the 1994 United States Census. It says a marketing analyst might be interested in finding factors that can be used to predict whether a potential customer is a high earner. The 94 US Census provided information that can inform such a model, and we have records from around 32,500 adults, and the output is a binary variable, okay? And it's just, do you make a lot of money or not, okay? And in 1994, that threshold was around 50,000, which is comparable to something around 90,000 today. And basically, does this person make more or less than 90,000? If they make over 90,000, they'll say high earner, and if not, they will be lower, okay? And we're going to see what kind of variables play a role, okay? And again, when we look at the relationship between these variables and what is a high earner or low earner or things like that, we have to be careful about drawing any kind of cause and effect conclusions, right? It could be, you know, we might look at someone's sex or something, okay? And we don't want to say that the reason why they are earning more is, you know, there could be all sorts of other factors at play, right? That could account for this, okay? So, so we have things like age, working class. Age looks like a numeric value, right? How old is the person? Final WGT, I think there's a few different variables here, right? Education expressed as a number, it looks like marital status, occupation, relationship, and things like that, okay? And so this we will load in. We're gonna load up our Tidyverse library, our modern data science library, modern data science with R library. The data is available at this URL, and we are going to read in the package using read CSV, read underscore CSV, using the URL, the address of our data, and then we're also going to provide column names, okay? And then what do? We're going to take the income variable and take the income and make sure it is categorical, okay? So when you look at the we've got greater than 50,000 and less than 50,000, we want to make sure that this is treated as a category. So we'll go ahead and do that. All right, so it's going to read that in, and indeed it reads 32,561 observations. Here, maybe I'll increase my size. Text, right? And so here we can take just a glimpse, and here's the output there. We can also capital V view our census data to get a glimpse of some of these things. Okay, and what we're going to do is we're going to just do we're going to do something so that we can do a validation test, okay? And we haven't really covered this concept in great detail here, but sometimes you want to see how well your model is working. Okay, you want to see, is my model any good? And really to test it is you want to give it new information that it hasn't seen before, right? Because as far as our predictive model goes, we want to know how well does it actually predict things, okay? And so what we want to avoid is we want to avoid like showing basically the answers and then coming back later and saying, hey, if I show you this thing, how do you categorize it, right? So it's kind of like if you're trying to teach somebody what is a chair, okay? And if it's what we want is the person to be able to figure out, what a chair looks like, okay? And so if you show them a picture of a chair and say, hey, this is a chair, you show them another picture of a chair and you say, this is a chair, and you show them a picture of a table and you say, this is a table, okay? What you want to do is you want to show them a new picture, a picture of a chair that they've never seen, and see if they can correctly identify that as a chair, okay? If you show them an old picture that you've already seen, then that person just might be using memory, right? They might just be recalling what they've already seen. And so here, an important idea is this concept of a testing set or a holdout set, okay? And so what are we doing? We are going to take, I'll go through this line by line, okay? We load up this package called Tidy Models, which loads up some functions for us. Right? It's a big package. Okay, so it takes a little while to load. We're gonna set the seed so if you wanted to follow along, you're gonna get the exact same results. Okay, and then we say, okay, we've got 32,561 rows, right? And we're going to use this function called initial split. Okay, what initial split does, okay, is it takes the data and it's going to split it. Okay, and here we're going to split it 80% training, 20% testing. All right, so we have 32,000 rows. We're going to take about 80% of that. So what is that? 80 times 32,000 is something around 25,000. Okay, something around there. Okay, we're going to take something around 25,000, 26,000 rows. Okay, and we're going to say, look at these 26,000 people and try to figure out who is going to make a lot of income and who is not going to make a lot of income. Okay, so look for patterns in these 25 to 26,000 people. Try to figure out a pattern so you can figure out who's going to make a lot of money and who's not going to make a lot of money. Okay, and now what we do is the remaining part. Okay, the remaining 6,000 rows, 6,500 or so. The remaining 20%, we're going to say, okay, now I'm going to test your ability, your pattern that you think you've recognized. Okay, here are some new people you've never seen before, and based on this information I'm giving you, you try to make a prediction on whether they are a high earner or a low earner. Okay, and we actually also have the answers, right? Because we're taking the full data. The full data is completely labeled, right? And we have the answers. Okay, so now we're doing some tests. We say, all right, you've got a system that you have a model that you think works as far as predicting who makes a lot of income and who makes less income, right? You've figured that system out based on 26,000 people, and I've got another 6,000 people to test you on, and let's see if you get these answers right. Okay, and that's how the testing set works. Does that kind of make sense? And so this function. Okay, what we do is we take the census data, the 32,561, and we say, hey, make a split. Okay, and we call this census parts. Right, so you see census parts. It's quite a big list. All right, it says, all right, well here's the data. Okay, and we're going to we have a list of 4. The first part is the data itself. Okay, and then it's got kind of a list of indexes and an output and an ID, and basically we're going to take that, and from census parts we can call training, which is going to take the training section of census parts. Okay, and then the testing portion. Okay, so we're going to take census parts. We're going to create a training data set. Okay, and so you can see training took around 26,000 of these rows, and the test will do the remaining 6,500. All right, and so now we've split these, and we're going to say, figure it out from the training and the testing part. Okay, and then so just so you can see, so we can see the number of rows here. We can also just ask how many rows, right? And we can see we got 26,048 rows in the training section, and we've got 6,513 in the test part. Okay. All right. And so what are we going to do? We're first going to just figure out what proportion of people are high earners. Okay. So let's take a look at this dplyr. Here we're going to just say, let's take the count. All right, that's going to be 26,000, however many people. Okay, and then we're going to we're going to take the count on this income, okay? So let me just show you line by line. So if I do count, okay, the count function, if you take it on and you give it a variable, it's just going to give you basically a table of how many things we have. So out of the 26,000, 19,763 were non-high income, less than 50,000, and 6,000 made over 50,000. Okay, and so what are we going to do? We're going to create a new variable called %. Okay, so we're adding a new variable to this. Okay, so we do the count, creates this table. We create a new variable called %. All right, and then what we do is we take this variable and we're going to just filter to just this row where we're over 50,000, okay, which we're getting 0.241. Okay, and then from here we're going to do pull, and we just get out that number 0.241. Okay, and that's going to be pi bar. Now there's lots of ways we could have done this. Okay, I mean, we could have just I could have just done train $ income, and there's many ways I could have done this, right? So I could have said, okay, give me this, and we could have said, is it equal to less than 50K? Whoops. I guess we want greater than or equal to 50. Oh, I'm sorry. I have it written. Greater than 50K, and then we could ask for the mean another way. This is another way we could have asked for it. Okay, we could have said how many, because when you do train $ income equals this, that would have turned it into a bunch of true and false values. And when you ask for the mean on a bunch of true false values, you know, it converts them all to zeros and ones, and it's going to give you the percentage that's ones. Okay, but anyway, in our training data, 24% are high income earners. All right. Oh, let me give you your first view quiz answer. Today's first view quiz answer is D. D as in dog. D as in dog. Okay. So the null model, okay, the null model doesn't take into account any predictor variables. It just says, well, overall, 24.1% of people are high income earners, and so if you gave me a random person and said, hey, do you think this person's a high income earner? I'm going to say probably not, but there's a 24% chance that this person is, and that's it. Okay, and what we want to do is we want to be able to try to improve that. Okay, and so if we say this person's not a high income earner, and if we just say that for everybody, how often am I going to be correct? I'm going to be correct around 76% of the time, right? Because here I said 24% of people are high income earners. And so when you pick a random person and you ask me, do you think this person's a high income earner? Right now, my model just says everybody is a no. Most of the people are non-high income earners. And so I'm just going to predict no for everybody. And how often am I going to be right? I'm going to be right around 76% of the time. Okay? It's kind of just like if you ask me, are you able to predict the weather? And I could go, in California, I can predict the weather like with 90% accuracy. Oh yeah, that sounds pretty good. Yeah, every day is sunny. Okay? And that's it, right? And it's not a good model, but I just say, hey, every day in California is sunny, and I'm going to be right like 90% of the time, right? And if you think about that, go, well, that's not actually a great model because we want to, but that's basically what we're doing. You just say, oh, the majority category, 75.9% of the time are non-high income earners. You're going to be right, okay? So that's going to form your baseline. If your model doesn't improve that, where you're accurate more than kind of this baseline where you're just going to predict whatever the majority category is, if you're not getting better than that, it's not really a good model, right? Right now, like if I just say, hey, it's going to be sunny, I'm going to be right 90% of the time. And if you say, well, I can do a better job, sometimes it's sunny and sometimes it's rainy if I take into account this step, and you're only accurate like 70% of the time, your model's not very good, right? I mean, that's if we're just going off of pure accuracy, all right? Now, we might have some other criteria, but basically, the accuracy of the model is going to be 76% of the time. Okay, so we can just kind of do this, and we say, all right, 0.759. Okay. So what we want to do is we want to be able to kind of compare our model to future models. Okay, and so there is a package called Yardstick. Okay, and it allows us to measure the performance of our models. Okay, this is all part of the tidyverse, right? You don't have to use this package, but what we're going to do is we're going to create our what we call the null model. Okay, and so this null model, notice what are we using for the predictor? We're using the number 1. Okay, we have to put something in there. And basically, we're saying the fact that we're using just the number 1 basically says, well, okay, we have to put something there, but this number 1 doesn't come anywhere from the data itself, right? We're not taking into account any of the individual traits in that row to help make our prediction. We're just saying predict income, and so in this case, we're just going to predict high income or low income, and right now the best predictor is just not a high income earner, and we're going to be right around 76% of the time. Okay, this is how it works with logistic regression using tidy models. We say I want to create a logistic regression model that's going to do a classification. The engine uses GLM, so this is just kind of what you have to do. And as far as the model itself, right here is specifying what we're using as a predictor, and right now we're just saying just use the number 1. Basically, don't use anything from the actual data, okay, as far as predicting, okay? We still have to provide data equals train because we need to use the income output in the training data, right? And that's where we're getting that 76.1 or 75.9%, 76%, okay? So this is our null model. We can take a look at this, all right? And it's got all kinds of stuff going on in there. But this will allow us to kind of see how it goes, okay? All right, so here we're going to take the training data. We're going to select two of the variables out of training data. All right, so let me just show you what happens here. Okay, we'll go line by line. All right, so here's my training data. We've got 26,000 rows, 15 columns. What we're going to do is we're going to just select 2 columns at a time, or just 2 columns. We're going to take the look at the income and then their capital gains. Okay, capital gains is basically how much money they made off of basically something like stocks or something like that. So capital gains is, if you invest in stocks or some kind of asset that appreciates or goes up in value, you call that capital gains, and you have to pay taxes on it. And basically, if you have to pay capital gains, it means you have enough money to go out and purchase stocks or go out and purchase value assets that appreciate in income, right? And this is kind of just the indicator of a little bit of wealth, at least certainly in the 1990s, okay, when this data set was created. Well, like today, you could just download an app and start investing in the stock market. But back in the 90s, that didn't exist. You had to open up a brokerage account at a stockbroker, and you had to, it's kind of like, I don't know if you ever watched Wolf of Wall Street, but you had to like basically call in and get something set up, and generally that was like something only the quote unquote rich people did, right? So here we're just using this variable, how much capital gains. Now capital gains is a numeric variable. Most people have 0 in capital gains, okay? But we're going to take a look at that and we're going to see, okay? And then so now what we're going to do is we are going to make a prediction, okay? So the prediction part, okay, look what this does, okay? So predict, we're going to say take the null model. So what's the null model going to do? It's going to predict everybody just isn't going to earn anything. This is its predicted class, right? So if I take this prediction and I say give me a count here, it should predict everybody as okay, here it just says everybody is low income earner. Okay, it's not a very good model. But what we're going to do is we're going to just add that column. Okay, so now what we have is we have income. We've got this variable capital gains, which right now doesn't help us make a prediction. Right now, we're just predicting everybody is low income. Okay, and we said, well, we're going to be right 76% of the time. Okay. So, and we're going to rename this prediction class into income null, and we could say, all right, give me the accuracy here. Okay, right. So here right now, again, all we're doing is we're predicting every single person is low income earner. This is the null model. We went through and we said, hey, 76% of people are low income earners. Let's just predict everybody be low income earner. And right now this is how accurate I am. I'm accurate 76% of the time. Okay, that's the null model. What we want to do is we want to say, hey, what if we actually take into account, this is what we call a confusion matrix. Confusion matrix is another way. Okay? Whoops. What is the confusion matrix? Okay? So the confusion matrix, if you guys can see this, maybe we'll just zoom in here, okay? Here, right now with the null model, we're making the same prediction for every single person, okay? All right, so as far as the predictions go, we're only predicting that every single person makes less than 50,000, okay? And so we are correct if the truth is that they make less than 50,000 and we predicted that they make less than 50,000. And we're correct 19,763 times. We are wrong 6,285 times because we predicted that these people make less than 50,000, but in truth, they make over 50,000, okay? So we are correct. This number plus this number is how often we are correct, okay? We predicted they make over 50,000 0 times, and they actually made over 50,000. We are correct, here 0 times. And this would be the number of times we predicted they make over 50,000, but in reality they made less than 50,000. Okay? So these two numbers are correct. These two numbers here and here are incorrect. Okay? Now right now we're just predicting every single person's a low income earner. And so, our confusion matrix only has entries in the top row. Okay, does that kind of make sense? What this confusion matrix is? All right, you want to be correct along your accuracy is how big your diagonal is. Okay, because this is your prediction and the truth. You want those to line up. Now, when you predict one thing and the truth is something else, these are incorrect. Okay, so we're going to make a logistic regression model here. Logistic regression model. And the only difference between this one is we changed the 1 to capital gain. Right? We're going to take into account this variable, capital gains. All right, so I'm using the exact same command that I did from the null model. Right? And we're going to predict based on capital gains. Rather than just using the number 1, which is the same for everybody, this actually changes from entry to entry. Some people have zeros for capital gain. Some people have larger numbers for capital gain. And so based on that, we're going to make a prediction. Okay? So let's go ahead and see how we've performed here. All right, so there's a few things going on here, okay? We're going to take the high income earner and we're going to just turn it into a numeric value, 0 or 1, okay? So let me just do select. We'll do income and high earner. Okay, and so basically if they are over 50,000, their high earner value is going to be a 1. Okay, so we're going to we're just adding that so we can plot it. Okay, now let's see if we can understand what's going to be happening in this ggplot command. This ggplot command says take this thing, on the x-axis put capital gains. How much money did they earn? On the y-axis put whether they are a high earner or not, and that's going to be 0 or 1. Okay, and then what are we plotting? We're plotting Geom count, which is not a thing that we covered. Okay, but Geom count is basically like Geom point. Okay, but it counts the number of observations at that location, and then we can use that to show how big that value is. Okay, so Geom count is like Geom point, okay, except it counts how many observations are located there. Right? We're also going to jitter our position so we can see it. We're going to put in some transparency there. The jitter arguments, width says jitter, don't jitter it horizontally. Okay? Because jittering it horizontally will make it appear like they earn more income or less income, right? Because the horizontal goes with their capital gains, okay? We don't want to make them look like they earn more or less in capital gains. But we are willing to jitter vertically in height, because height, we know there's either a 0 or a 1. 0 for low income, 1 for high income earners. And so we're willing to jitter vertically, but not horizontally. So here, let me just show you what this looks like so far. Okay, so this is kind of our plot so far. And what we want to do is, this is our plot. And so we can see, big circle here. This is everybody who's low income and has 0 in capital gains, all right? And this is everybody who's high income and has 0 in capital gains, right? So the circles indicate how big our dots are. Now we're going to add a smooth line. So this says, and you know what? Let's move this up here. Actually, what we want to do is we're going to change the x-axis to a log scale, which is just often what we have to do. Okay, so now we have a log scale. So $100, $1,000, $10,000, and $100,000 as far as capital gains go. Now, unfortunately, what's unfortunate with a log scale, okay, is that you can't plot a 0 anymore, right? Because log of 0 becomes negative infinity. So we do have a bunch of people with 0 and capital gains, but we can't plot them here, unfortunately, in the log scale. But it does help us, because look at this person. This person has 100,000 in capital gains, right? It's not, they just show up over here, okay? All right, and what we're going to do is we're going to add a smoothing line. Family binomial says, hey, it needs to be zeros or ones here, okay? Color, you can actually use Dodger blue if that's the actual name of the color, and then we'll go ahead and add a horizontal line here. All right, and so here's the plot, and basically, if the prediction goes over this 0.5, it's going to predict as high income earner, and if it's below 0.5, it's going to predict low income earner. And we want to know, okay, how often are we correct? How often are we correct? Okay, does this kind of make sense as far as how this model is working? So let's go ahead and try this out. Okay, so this is the plot, and so now we're going to say, okay, let's figure out how accurate our model is. All right. So our predictions, we're going to take the predictions using our training data, using this model, right? The model that we're using. Our logistic regression model, okay? And now we'll create our confusion matrix here. Let's compare this to our old confusion matrix and our new current confusion matrix. All right, so under the null model, we predicted every single person is a low income earner. Okay, with our log model, okay, we're predicting some people are low income earners and some people are high income earners. Okay, we are correct. So here we predicted low income, and in truth they were low income. We were correct this many times. Okay. Over here, we predicted low income, but they were actually high income. This happened 5,000 times. Here we predicted high income, but they were actually low income. This happened 203 times. We predicted high income, and they were high income 1,270 times. So the number of times we are correct is this number plus this number. Okay, and we are wrong this many times. So we are wrong 5,218 times if I take these two things. How often are we wrong here? We are wrong 6,285 times. So we went from wrong 6,200 times to wrong 5,200 times. Okay, so we've improved by about 4%, 4 percentage points. Okay, but that's just taking into account just one variable, the capital gains, but that helps us improve, right? So our accuracy, if we go through and we say, hey, what is our accuracy? It now says around 80%. We're accurate 80% of the time. Okay, so before we just predicted everybody's low income, and we were right 76% of the time, 75.9% of the time. Now we say, hey, tell me how much you made in capital gains. Oh, okay, if you make over, it looks to be what? I don't know. 5,000, 6,000 or 7,000 in capital gains. If you made over 6,000 or 7,000 in capital gains, we're going to say, I'm predicting you are a high income earner. And if with that one simple rule of saying, if your capital gains was over 6,000 or 7,000, we're getting an increase from 76% to 80% accurate, okay? Which is, it doesn't sound like much, 4 percentage points, okay? But we're going wrong from around 1 in 4 times to being wrong around 1 in 5 times. So that's a decent improvement, okay? Decent improvement, I think. All right, this is an interesting plot here. Okay, this is called the auto plot. All right, what is this? Here it says, what is your prediction and how often are you correct? Okay, so we predicted less than 50,000. Under the null model, we predicted every single person is less than 50,000. And we are correct this percent, 76% of the time, or we're wrong this percent of the time. Okay. We're basically plotting the confusion matrix. The confusion matrix is getting represented with area. Okay. So we are correct here and here. Okay. Tn is true negative. TP is true positive. FP is false positive. Fn is false negative. Okay. So we predicted less than 50,000, and they were less than 50,000. True negative, we're correct this much. We predicted more than 50,000, and they were more than 50,000. True positives this much. We predicted more than 50,000, and they were less than 50,000 this often. Okay, this is our false positives. We thought they made more money. In reality, they didn't. Here, these are false negatives. We predicted that they make less than 50,000, but in reality, they did. Okay, so we can see this is what we want to see. We're happy with this. This is very thin. Okay, we're not so happy about this. What we would like to see is this true positive to be a lot taller. We want to be like, when they were actually high income earners, we predicted high income earners, and our false positives would be a lot lower. But right? I mean, our false negatives would be a lot lower. This false negative is still pretty big. Okay, but we do get some improvement, right? We do get some improvement. Do these plots make sense as far as what's going on? Okay, good. Oh, I'm out of time. Okay, last two view quiz answers are E as in elephant. E is your second one. The third one is C as in cat. C as in cat. Okay. Okay. Well, this is just kind of getting started, and honestly, this is still an improvement. Okay, of kind of creating a logistic regression classification model, right? And so if your data set involves trying to predict some kind of classification, okay, I would say look at this section. All right, and this one again is using just one predictor variable, the capital gains, but you could make your model stronger by adding, or not necessarily stronger, but just you might be able to get higher accuracy in prediction by adding another variable or something like that. Okay, we'll end here for today. Again, on Wednesday, I won't have a formal lecture, but I will be here to provide any kind of advising, any kind of help. All right, and again, don't hesitate to come visit me for office hours. Now, I will not have office hours on Thanksgiving Day. Okay, so just want to give you a heads up there. Okay. All right, we'll see you guys on Wednesday maybe. If not, have a happy Thanksgiving, and we'll see you guys, whenever I see you guys next, okay? All right, thank you.